Welcome to the November 2025. This is the Edexcel IGCSE paper 2H. All right, question number 1, finding the midpoint. So halfway between the x coordinates, halfway between the y coordinates. Use a formula if you like. It comes out as 610. Part 2, pair simultaneous equations. The y's are already lined up quite nicely, so I can add the two equations together. 8x equals 20, divide both sides by 8x equals 2.5. Substitute that into either equation and solve it to get that y equals negative 1.5. So x equals 2.5, y equals minus 1.5. Fractions are absolutely fine. Question 3. So box with red bricks, blue bricks and yellow bricks. So the total number of bricks, let's call that n. It's going to be 9 plus 43 plus y. We know that 7/20ths of the bricks are yellow bricks, so 7/20ths of n will be equal to y. And essentially we have simultaneous equations. I'm going to multiply both sides by 20, so 7n equals 20y, and divide both sides by 7n equals 20 over 7y. Substitute that into the other equation, 27ths of y equals 52 plus y. Subtract y from both sides, 13/7ths of y equals 52. Multiply both sides by 7, divide by 13, we get y equals 28. Each brick is 35 grams, so 28 times 35 is 980 grams. It's the total weight of the yellow bricks. Question 4, we've got similar shapes here. So working out the scale factor of lengths, 60 divided by 4 gives us 15, and then 15 divided by 3 gives us 5, so it's 5 centimeters. Question number 5, finding a percentage increase. So take the new amount, subtract the original amount, divide by the original amount, times by 100. 87 minus 75 over 75 times by 100 gives us 16%. For part B, compound interest, 960 times by 0.8 cubed. 0.8 represents a 20% decrease. Over 3 years, so cube it is 491.52 Swiss francs, 491.52 for part B. Question 6, the three little circles inside the big circle. If we call the radius of the big circle capital R, the radius of the little circle little r, the circumference of the large circle is 160, so using 2 pi r, 2 pi times capital R is equal to 160, so the radius of the larger circle is 80 over pi. Now there are 3 little radii on each big radii, so little r is going to be the larger r divided by 3. So in this case it's going to be 80 divided by 3 pi for the radius of the little circle. Finding the area of one small circle, well, it's pi r squared, where r is little r for us. So pi times by 80 over 3 pi all squared. Plug that in, round it to 3 sig figs, we get 226 centimeters squared. Missing a squared there. Question number 7, factorising x squared plus 2x minus 48 is x plus 8, x minus 6. And then solving that, we get x equals negative 8 or x equals 6. For 8a, standard form to an ordinary number, move the decimal point 4 times if you like, 57,600. For part A, 57600. For part B, you just plug it in your calculator if you want. You can simplify it down. I've added the two numbers in the numerator together to get 308 times 10 cubed, all over 4 times 10 to the negative 2. and that's 77 times 10 to the 5. Turning that into standard form, 7.7 times 10 to the 6. If you just plugged it into your calculator and then worked it out in standard form as 7.7 times 10 to the 6, that's absolutely fine. Question number 9. So 120 counters in bag A, times that by the 0.45 probability of it being red is 54. So 54 red counters in bag A. In bag B, 80 times 0.3 is 24. Add those together, that's 78 red counters in total. 120 plus 80 is 200, so it's 200 counters in total. 78 of those are red, so 78 out of 200. You can simplify that if you want to. Question 10, less than 1, so an empty circle at 1 and an arrow going to the left. Part B, we've got y is greater than or equal to x, y is less than or equal to 4, and x is greater than or equal to -3. Question number 11. We've got ourselves a right-angled triangle. Work out the perimeter. So a half times a base times the height will be 240. So a half times 30 times the length AC is 240. Divide 240 by 15, you get 16. So A to C is 16. We need to work out B to C as well to find the perimeter. So using Pythagoras, we get the square root of 16 squared plus 30 squared, which comes out as 34. Add together our three lengths, 30 plus 16 plus 34 gives us a perimeter of 80 centimeters. Question number 12, plug 1 in and you get 2.5 out, plug 2 in and you get 2 out. And then to draw the graph, and plot each one of the points, so 0.5 and 4.25, 1 and 2.5, 2 and 2, 3 and 2.17, 4 and 2.5, 5 and 2.9, and 6 and 3.33. Trying to be as careful as possible with those. And then I have a go at drawing the line through all of them, a nice smooth curve. Yours will probably look better than mine. Smooth as possible, passing through every point. And we get our graph. All right, for part B, we want to equate that to 6. So the first thing I'm going to notice is that I need to take half of both sides so that the left-hand side is equal to the graph I already have. So half of x plus 4 over x will be equal to 3. I'm going to draw the line y equals 3 on my original graph as a horizontal line going through 3. And I'm going to read off the x-coordinates of the intersection of y equals 3 and the curve that we've already drawn. And those come out as 0.7 or 5.3. Now, because you're reading these off a graph, there's a bit of leeway. So anything between 0.7 and 0.8 is acceptable for the first value, and anything between 5.1 and 5.3 is acceptable for the second value. So mine are just in range. Question 13. So to the power of 2/3, 125 cube root it and square it to get 25. X to the 6 to the 2/3 is x to the 4, and y to the 15 to the 2/3 is y to the 10. So 25 x to the 4 over y to the 10. For B, 64 is the same as 4 cubed. So 64 to the power of p is equal to 4 to the power of 3p. Subtract the powers. We get 4 to the n is equal to 4 to the m subtract 3p. Therefore, n must be equal to m subtract 3p. Question 14. The median, well, we've got 40 bits of data, so the median's at 20. Read off the value at 20. I got 27. Anything between 27 and 27.5 is acceptable. For the interquartile range, we're going to draw horizontal lines at 10 and at 30, and then read off the corresponding heights for those. I got 35 and 19, and then subtract the lower quartile from the upper quartile to get 16. So the interquartile range, anything between 15.5 and 17.5 is acceptable. For question C, so I'm going to draw a line going up from 40, see where it meets the curve, and then read it off. I make that the 34th position. So if I subtract the 34 from the 40 in total, that gives me 6 premium plants. Times that by the 30 euros for each one of them. That's 180 euros in total. Question 15 is a very straightforward circle theorems question. AI, the angle is 96, and you have to learn these. Make sure you get the key words. The angle at the center is double the angle at the edge would be sufficient. Angle, center, double, and edge are the key words. You can put the angle at the edge is half the angle at the center if you want to use the other version of it. BI is 132, and that is because opposite angles on a cyclic quadrilateral sum to 180 degrees. We need opposite angles, we need cyclic quadrilateral, and we need a sum of 180 degrees for that one. There aren't many of them, do just learn them. Question 16. So turning a recurring decimal into a fraction. So if x is 0.3787878 and so on, then 10x will be 3.78 recurring. Times that by 100, we get 1000. X is 378.78 recurring. If we subtract 10x from 1000x, we get 990x. The recurring decimal bits cancel. 378 subtract 3 is 375, and so 375 over 990, which simplifies down to 25/66 as the question wanted. Question 17, t is proportional to 1 over the square root of m. It's 1 over because it's inverse proportion we're talking about here. To turn that into an equation, t is equal to k over root m, where k is the constant of proportionality. We know that t is 15 when m is 36, so I'm going to plug those in. 15 equals k over root 36. Root 36 is 6, so 15 equals k over 6 times both sides by 6. We get k equals 90. The equation connecting t and m is therefore t equals 90 over the square root of m. Question number 18. We know one of the students is selected at random. Work out the probability that the student studies Latin or Sanskrit. So let's create an equation adding together all of the numbers in our Venn diagram. We know they must sum to 40. We can solve that to work out x. Collect like terms on the left-hand side. 26 plus 7x equals 40. 7x equals 14. X equals 2. I can fill in the Venn diagram with the actual numbers. We've got an x is 2, 2x is 4, 4x is 8. We're looking at Latin or Sanskrit, so there's 7 in Latin, there's 12 in Sanskrit, so 7 plus 12 out of 40, which is 19 out of 40, and that's the probability of picking one at random. Question 19, g of 3, plug 3 into g, 3 over 2 times 3 minus 1 is 3/5. For part B, finding g of f of x, plugging the function f of x into the function g, we're going to get 3x minus 2 all over 2 lots of 3x minus 2, subtract 1. And that denominator simplifies, so the final compound function 3x minus 2 over 6x minus 5. Don't be tempted to cancel within that fraction, nothing will cancel. leave it alone. Question 20. We can see from the denominator, the 2a part of the quadratic equations formula, that must be equal to 10, so a must be equal to 5. The 2 root 39 will be equal to the square root of b squared minus 4ac part of the quadratic equation, so 2 root 39 is equal to square root of 16 minus 4 times 5 times c. Square both sides, 156 equals 16 minus 20c. Bring the 20c onto the left, the 156 onto the right. We get 20c equals minus 140, therefore c is equal to negative 7. A is 5, c is negative 7. Question 21, the histograms question. It tells us that 20 of the trains arrive between 10 and 15 minutes late, so the area of that bar between 10 and 15 is 20. Its base is 5, so its height must be 4. 5 times 4 is 20. And therefore we can work out the frequency density scale. Each large square is going up in 1, each mini square up in 0.1s. Now we want to work out an estimate for the trains arriving later than 25 minutes. I'll section off the 25 plus 15 plus 10 plus 14 for the areas, which is 39 in total. Question 22, we're given a cubic to play about with. We're told that there are 2 points with a gradient of 11, and we've got to find the equation of the tangents to the curve at those 2 points. The first thing I'm going to do is differentiate, so 3x squared minus 16. After I've differentiated, I'm going to set dy by dx as 11 and solve the equation. Add 16 to both sides, divide both sides by 3, and then square root. So x is going to be plus or minus 3. Let's deal with x being plus 3 first, plugging it into the original curve to work out the y coordinate. 3 cubed minus 16 lots of 3 plus 7. Y comes out as negative 14. It wants the tangent in the form y equals ax plus b, so substituting x to be 3 and y to be negative 14 into that, minus 14 equals 11 times 3 plus b. In this case, subtracting 33 from both sides, we get b equals minus 47. For the other point, when x is negative 3, substitute that into the original equation of the curve, and we get y is equal to 28 once you calculate that. Now the equation, again, of the tangent y equals ax plus b, I'm going to substitute negative 3, 28 into it and solve the equation. So 28 equals 11 lots of negative 3 plus b. 28 equals negative 33b. Add 33 to both sides, we get b equals 61. So the two possible values of b are negative 47 and 61. Question 23, this is to do with scale factors of lengths, areas and volumes. We get given the scale factor of areas. It's going to be 200 to 450. So our ratio is 200 to 450, not 672. Oops, that is a mistake. However, 200 to 450 does simplify to 4 to 9. Square root both of those to get the scale factor of lengths, which is 2 to 3. And the scale factor of volumes is therefore each one of those cubed 8 to 27. So if we take the volume of shape P, 672, divide it by 8, times it by 27, we get the volume of shape Q, which is indeed 2,268. Question number 24, the upper and lower bounds question. So I'm going to list the upper and lower bounds for each one of these lengths. So the lower bound of n is going to be 10.25, the upper bound of n is 10.35, the lower bound of p is 7.235, the upper bound of p is 7.245, and the lower bound of Q is 4.385, and the upper bound for Q is 4.395. So the upper bound for D, we're trying to make this as big as possible, so we're going to take the upper bound of N. I want the denominator to be as small as possible, so I'm going to take the lower bound of P and the upper bound of Q, because I'm subtracting it. And so that's going to be 10.35 divided by 7.235, subtract 4.395. Make sure you show the calculation with all those values in it. And when you plug that in, that comes out as 3.644. For the lower bound of D, well, this time we want it to be as small as possible. So we take the lower bound for N, the upper bound for P, and the lower bound for Q. So we want the numerator to be as little as possible and the denominator to be as big as possible. So that's 10.25 over 7.245, subtract 4.385. When you plug that in, you get 3.5839. Then looking at our two possible values of D, well, they will round to the same number to one decimal place. You can't go any further than that, so 3.6 for one decimal place. Question number 25, this is the arithmetic sequences question. It tells us that the first term, which I'll call A, is 10, and the 20th term is 86. U20 is 86. It also tells us that the 20th term is 86, so if I use the formula of the nth term, a plus n minus 1d, we'll get 10 plus 19d will be equal to 86. Subtract 10 from both sides, divide by 19, and we get d is equal to 4. Now the sum of n terms is 5,194, so I'll use the formula for summing n terms of an arithmetic. You get given this one at the start of the paper. N over 2 lots of 2a plus n minus 1d, and that allows me to construct an equation, n over 2 lots of 2 times 10 plus n minus 1 times 4. That's going to equal 5,194. Expanding the middle bits and simplifying inside the bracket, we get n over 2 lots of 20 plus 4n minus 4, or 16 plus 4n inside the brackets. Expand those out, and we'll end up with 2n squared plus 8n equals 5194. We have a quadratic equation, so subtract 5,194 from both sides. I've simplified by dividing everything by 2. And you can use a quadratic equations formula if you choose. Factorized n minus 49, n plus 53 equals 0. N can't be negative because it's counting the number of terms in a series, and so therefore n must be 49. Question 26, the cone sat on the hemisphere. So we are told that the total volume of the solid is 504 pi. So 1/3 pi r squared h for the cone, 1/3 pi times x squared times 5x, plus the volume of the hemisphere, that's 2/3 pi r cubed. R in that case is x. That's going to sum to 504 pi. If I divide everything by pi and start collecting bits and pieces, 5/3 x cubed plus 2/3 x cubed equals 504. 5/3 plus 2/3 is 7/3. Times by 3, divide by 7, we get x cubed equals 216. Therefore, we can deduce that x must be 6 for this one. The volume of the cone, 1/3 pi x squared times by h, in this case now 1/3 pi times 6 squared times 30, and that gives me a volume of 360 pi. Therefore the mass of the cone, which is made of copper, is going to be the volume times by 9. which is 3,240 pi. If we subtract the mass of the cone from the total mass of the solid, so 5,472 pi, subtract 3,240 pi, it gives us the mass of the hemisphere, which is 1,512 pi. Lastly, to find the density of the hemisphere, we can divide its mass by its volume. So 1,512 pi divided by, and then 2/3 pi r cubed, 2/3 times pi times 6 cubed. Plug that in and you get 10.5 grams per centimeters cubed. Well done if you got that one. That was the last question. All right, bye.